Hello and welcome back to another video. In today's video we will be explaining what would happen if our Earth was cubed. If you enjoyed this video, please subscribe and like. Without further wasting your time, let's get into today's video. Have you ever wondered what would happen if the Earth was a cube? Just picture it, our planet not as the familiar round orb we know and love, but as a six-sided box floating in the vast expanse of space. It's a strange thought, isn't it? But it's a thought that opens up a universe of peculiar possibilities. You see, the shape of celestial bodies, such as our own planet, is no accident. It's a result of some fundamental physical laws. Planets are round because gravity pulls matter into a spherical shape. The force of gravity pulls equally from all sides, making a sphere the most energy-efficient shape. But what if, for some cosmic twist of fate, Earth was not a sphere but a cube? How would that change our world? Would gravity still function the same? Or would we find ourselves living in a world of corners and edges, a world that defies our current understanding of physics? Imagine standing on one of the corners of this cube Earth. Would you feel like you're standing on the peak of a mountain? And what about the edges? Would they feel like steep cliffs? These are just a few of the many intriguing questions a cubical Earth raises. But it's not just about the physical consequences. A shift in Earth's shape would also mean a shift in our understanding of the universe. We would need to reevaluate our laws of physics, rethink our theories about the formation of planets, and perhaps even reconsider our place in the cosmos. A cubical Earth may seem like an absurd idea, but it's these kinds of thought experiments that push the boundaries of our understanding, that challenge us to think beyond what we know and explore the uncharted territories of the unknown. So, as we delve into this thought experiment, let's keep an open mind. Who knows, we might just discover something extraordinary. Now, let's dive into the perplexing possibilities of a cubical Earth. Gravity, as we know it, may behave quite differently on a cubical Earth. Let's take a moment to understand gravity in our current spherical world. This force that keeps us grounded and holds everything together is essentially the attraction between two masses. The larger the mass, the stronger the attraction. Our Earth, being a sphere, pulls everything towards its center. This means no matter where you stand, you feel the same force of gravity. But what if our Earth was a cube? Well, things would get a little weird. Rather than pulling everything towards a single point at the center, gravity on a cubical Earth would pull things towards the center of each face. This means if you were standing near the edge of a face, you'd feel like you were standing on a steep hill, being pulled towards the center. The corners and edges of the cube would have less gravity due to their distance from the center of mass. This uneven distribution of gravity would create some bizarre and potentially dangerous situations. Imagine skyscrapers leaning inwards, rivers flowing uphill, and perhaps even peculiar health effects due to the uneven force on our bodies. The pull of gravity on our bodies helps maintain our bone density and muscle strength. With varying gravity, there could be places on this cubical Earth where our bodies could become weaker or stronger, based on the gravitational pull. And what about the oceans? They'd be pulled towards the center of each face, creating 6 huge square oceans separated by land at the edges and corners. These drastic differences in gravitational pull could potentially create towering walls of water at the center of each face, with dry land at the corners and edges. This odd cubical world would certainly pose challenges for life as we know it. Physical structures would have to be designed differently, travel would become a gravity-defying adventure, and the gravitational variations could even affect how life evolves. So gravity would not be our friend on a cubical Earth. With a cubical Earth, our understanding of climate would be turned on its head. The Earth's spherical shape plays a pivotal role in how climate patterns form. Because of the curve of the Earth, the sun's rays spread out differently across the planet. Near the equator, sunlight hits the Earth directly, leading to high temperatures and tropical climates. The poles, on the other hand, receive less direct sunlight, yielding chillier climates. The Earth's tilt on its axis further contributes to the change of seasons. But what if Earth was a cube? Picture this, 6 flat faces, each with its own climate zone. The corners and edges of the cube would receive less sunlight, making them colder than the center of the faces. Consequently, our planet might have 8 polar regions instead of 2, located at each corner of the cube. The flat faces of the cubical Earth would receive sunlight at a consistent angle throughout the year, meaning no change of seasons as we know them. Each face would have a perpetual season. Eternal spring, summer, autumn, or winter, depending on its orientation relative to the sun. This uniform climate might lead to more extreme weather conditions. Without the tempered effects of seasonal change, Areas of the cube that are always hot could become even hotter, leading to intense heat waves and droughts. Regions that are always cold could plunge into deep freezes. The cube's edges and corners, with their reduced sunlight, might experience violent weather as cold air from these areas clashes with warmer air from the faces. Imagine hurricanes and tornadoes becoming common occurrences along these boundaries. Ocean currents too would change dramatically. The cube's shape could disrupt the flow of warm and cold water around the planet, altering marine ecosystems and potentially leading to more frequent and severe storms. So, while a cubical Earth might sound like a fascinating concept, it's clear that such a drastic change in our planet's shape would have profound and unpredictable effects on our climate. Our familiar weather patterns would be a thing of the past on a cubical Earth. Imagine trying to live on a world where gravity and climate are wildly different. Life on a cubical Earth would be quite a departure from what we're used to. The unpredictable nature of gravity and climate, the two fundamental elements for life, would present unique challenges to both humans and animals. Let's consider the wildlife first. Animals have evolved over millions of years to survive in their specific habitats. They're finely tuned to the gravitational pull, the climate, and the ecosystem around them. On a cube Earth, these conditions would be vastly different. Animals accustomed to a stable environment might struggle to adapt. Migration patterns would be thrown into chaos, and food chains would be disrupted. But nature is resilient, and we might see the rise of new species adapted to these unusual conditions. For us humans, life would be no less challenging. Our bodies are designed to function optimally under the Earth's gravity. A variable gravitational force would affect our physical health in unpredictable ways. We might need to evolve to have stronger bones and muscles to cope with the changes in gravity. In terms of climate, the extremes would be much more severe. The corners of the cube would be colder and drier, while the centers of the faces would be warmer and wetter. This could lead to a shift in human habitation. We might see cities spring up in the centers of the faces, where the climate is more predictable, and the corners might be left uninhabited. Culturally, this new world order would surely affect our societies, economies, and even our philosophies. Our understanding of the universe, our place in it, and our relationship with nature would all be fundamentally altered. In this alternate Earth, life would be strange, challenging, and different, but not impossible. Through adaptation and evolution, life finds a way to persist, even in the most extreme conditions. Life as we know it would face incredible challenges on a cubical Earth. A cubical Earth offers a fascinating, if challenging, thought experiment. We've journeyed through four corners of a hypothetical cube-shaped world, exploring the intriguing implications of a world reimagined. Let's take a moment to reflect on the key points we've uncovered along the way. Gravity, the invisible force that keeps us anchored to the ground, would behave differently on a cubical Earth. Rather than pulling us towards the center from all directions as it does on a spherical Earth, gravity would pull us towards the center of each face on a cubical Earth. This would result in a rather disorienting experience of walking uphill towards the edges and corners of the cube. And what about the climate? A cubical Earth would have a vastly different climate system. With 8 corners receiving less solar radiation and 6 flat faces receiving more, the temperature differences would be extreme. The faces would be scorching hot deserts while the corners and edges would be freezing cold, resulting in a planet with limited habitable zones. Life on a cubical Earth would face countless challenges. The extreme climates, the unusual gravity, and the sharp corners of the world would make survival difficult. Evolution would need to take a different course, adapting life forms to these unique conditions. Reflecting on these thought-provoking points, it becomes abundantly clear how crucial Earth's spherical shape is to life as we know it. The sphere is a perfect shape, evenly distributing solar radiation, allowing for a stable climate and generating a consistent gravitational pull. It is this extraordinary balance that allows life to thrive in all its stunning diversity. So, as we wrap up this intellectual journey, let's appreciate the spherical wonder that is our Earth. The spherical shape, so simple yet so profound, plays an integral role in sustaining life. So, next time you gaze at our round blue planet, spare a thought for the extraordinary balance that makes life possible here.